Okay, so we're going to split section C into 3 parts, but all of these are dealing with quantitative data and we're graphing them. So that's the strategy. Okay, so discrete variable is a quantitative variable that is countable. It has gaps in between them and a number line. So these are things that are discrete. There's stuff in between. It's not continuous. So discrete. It's actually a term you learn in calculus. If you've ever taken calculus, it might make more sense. You go, oh yeah, discrete variable, countable, has gaps in between. Continuous has no gaps. Right, this can take on any value in between the numbers there. One way of displaying a graph is a dot plot. It's probably our first line of defense. It's our first way of looking at data, and we use it quite a bit. It's easy. You can see each data value. Actually, you can see it on the dot plot. So sometimes some graphs you can't see each individual data value. You can with a dot plot. You can see at 10 we stack these guys. So if you see like 2 on top of 10, that means there's 2 10s there for lead level. How to make a dot plot. So there's 3 steps. You want to draw and label the axis. The most forgotten step there is to not label the axis, actually. Let's see if I can put this down just a little bit. There we go. Make sure you put a label at the bottom or something. Scale should all be like by the same amount. You're going up by 10s here, so you want to have that consistent. Don't make the scale where you kind of haphazard. I see that sometimes as well. Scale the axis, smallest to biggest, you know, and keep that consistent. And it has to go from the smallest to the biggest. It's okay to exceed the biggest value or go a little smaller than the smallest value. That's okay, but you have to have at least that much space in there. Plot the values, just mark a dot there. Pretty easy to make by hand. Well, so describing shape. This is a big deal. We do this again all year. You see that first shape there on the right is roughly symmetric. It kind of looks symmetric-ish, and we're not sticklers on that usually. And roughly, we like to say words like approximately symmetric or roughly symmetric because it's probably not perfectly symmetric. Most graphs don't work out that way. So you kind of safeguard yourself, approximately symmetric or roughly symmetric. The left side similar to the right side. Skewed to the left, so it kind of slopes down like that and extends out further to the left. That is skewed to the left, and so that one's skewed to the right. The skewness is the long tail. Oftentimes those points on the very ends there are outliers. Sometimes that little point there at the end of the right and the bottom right might be an outlier out there. You can think of it as skiing instead of skewed to the left. You ski left on that one, so that would be skewed left. This one may not be like perfectly flat, but it's kind of flat-ish. And so most of the data values, when you roll a dice, you would expect you have an equal chance of getting a 1 or a 6 or a 5 or a 4 or 3 or 2. They're all equally likely. So if you roll a lot of rolls, you would expect this graph to be relatively flat on the top. So we call that uniform. So approximately uniform is when it's flat across the top or flat-ish across the top. So we describe 3 things when you describe a graph. You want to describe shape, center, variability, actually a 4th thing there. So also unusual features, and in most cases that is there an outlier or not. So shape, center, variability, and is there an outlier? So shape, in this case, we would say it's definitely skewed to the right. It's not bimodal. Bimodal means there's more than one peak, or trimodal. This seems unimodal, so there's a single peak at 0 there. The middle value, the median, is somewhere around 3. You would be able to calculate that by counting the number of dots, finding which 1 or 2 dots are in the middle, and then counting to the left, to the right, and find that it actually is at 3. That was not a guess that they did there. They actually counted that out and did that. The lead levels vary from 0 to 104. So that's a very rudimentary kind of variability. So we're going to talk later more about like IQR, interquartile range. Standard deviation is a measure of spread. Even range is a measure of spread as well. But just think of variability as a measure of spread there, or how much it varies. In this case, we're just basically saying between 0 and 104 are where the data values vary from. And it does seem quite obvious there's at least one outlier, and that would be at 104 there. And then the other two at 42 might be outliers. In fact, they probably are, but we don't know how to find those yet. So we're just kind of guessing, but sometimes it's obvious. Outlier is a number that's way bigger than everything else. Okay, so we're done with today's lesson. Let's just practice this a little bit. I'm going to show you how to do this maybe by hand and also with your calculator. So by hand on this one, make sure that if you're finding, what was the question asking? Find a dot plot. Okay, so if you're making a dot plot, the biggest thing you'd want to do here, whoops. My pen is not working like I hoped. The biggest thing for this type is when you do the, let me see, I can get this. Yeah. So if you're doing a graph for this guy, you'll want to scale it out. And so you have to think about the scale. In this case, it looks like it goes from maybe 163 at the highest to about 110 at the lowest. So you kind of draw your line and figure out how far you're going. You could go by 10s, you could go by 5s, but just be consistent on your scale and then mark the dots accordingly, approximately where they are. And if there's two that are on top of each other, try to do that and make sure they are on top of each other. You can also let your calculator do that. So let's do that. That'll be easier for me to show here. I've had trouble drawing on using the other one. Okay, so on a calculator, hit the home key, go to the list and spreadsheet option. It's the green, looks like an Excel spreadsheet kind of there at the bottom. This is, what's this data about? Here are the lengths of the Bond movies. Okay, so at the very top, so put your cursor at the very top and put length or something like that. I'm just calling it length, so that's what these numbers represent. Start typing in all the numbers. So 15. So you start on cell A1 there. You get kind of nervous because it's easy to skip one here. Hopefully that didn't happen. I like to check and make sure I at least have the right number of them. So there should be 1, 2, 3, 4, 5, 25, 26, 27. Okay, so I have the right number of terms, so hopefully I typed it in there right. And so typically I'll go to a calculator page now, not a scratch pad. So I'm going at the bottom there to a calculator page. Scratchpad doesn't talk to the listen spreadsheet page, so you don't want to do that. So I added a calculator page. It's page 1.3 for me, but it should be one more than the previous page. To go back a page, hit Control left arrow. To advance a page, Control right arrow, and you can go back to those pages if you need to. So go to menu, and we want to go to statistics. And the first choice is stat calculations. And this is one variable statistics. There's only one variable, it's just length here. And so I'm going to press enter. The number of lists, we only have one list. The name of the list, X list, if you click there, it'll give you an option just to click it. And usually that's all I change unless there's a frequency list, which we have done before, but not today. So say OK, and it gives you all this information. If you mouse up one click, it shows you from the start. It has so much information, it kind of overspills the screen there. But X bar, that first term is 128.59. That's your mean. We'll talk about some of those other things like SX is your sample standard deviation. Sigma X is your population standard deviation. And there it also has the median of 130 at the bottom there. So what's this question ask for? What percentage of the movies make a dot plot? Oh, so we have to make a dot plot. Okay, so this gives you all the stats about it, which again, you're going to want a lot as well, but it also can draw a graph for you. So if you hit the home key and go to, we love data statistics on Inspire. This really is a nice dot plot. You can't do this on a T84 if you have friends who have one of those. So we're going to this guy. It kind of randomly plots the data up there. It's kind of weird, but if you hit tab right there or click at the bottom of the screen, you can add a variable and the only choice is length. I'm going to add that. And so it draws the dot plot for you, which is very nice. And so it scales it for you and everything. It says how many to the left. So 120 is right there. So it looks like 1, 2, 3, 4, 5, 6. It's hard to tell. I'm just going to stretch that out a little bit so I can see it a little better. It does look like there's one at 120, 1, 2, 3, 4, 5, 6, 7. There are 7 values that are 120 or less. 120 is 2 hours, right? So 7 of the values of the 27 values are 120 or less. How many of the values are more than that? That would be 20 out of 27. So you would say 20 out of 27, which is 74.1% of the movies are longer than 2 hours because 7 of them are 2 hours or less there, according to the dot plot. You can see by hand, it's almost a little bit more clear. Sometimes on the calculator, it kind of has to scrunch up that dot plot, so it's kind of hard to see. So sometimes by hand is good. I want you to be able to do it both ways. Do one, and the crunching the numbers is really where the calculator shines there. It's so big of a pain to do that by hand, so let the calculator do that for you. Here's the dot plot that's given to us. It's about the average students per faculty member in colleges or universities. So you can see there's a little bit of variation there. Okay, so describe the shape. So what is the shape of this one? Probably the only big thing I would see is it looks roughly symmetric. It's not perfectly symmetric, but it looks roughly symmetric. And that's probably all I'd say about that one. They said is roughly symmetric with a single peak at about 14. So I guess there's a peak at about 14. There's barely a peak at 14, but that could be true. I think that's okay. This one, okay, this one's a little bit more obvious. Do you see those outliers on the right or potential outliers on the right? So this one is definitely skewed to the right. That's the giveaway, is those outliers there. And so it maybe has a peak around 2 there. Let's see what they said. 2, they actually put in writing. So skewed to the right with a single peak near 200,000 students. Because each of those numbers represent 100,000 students, it would be more proper to say 200,000 So always look at that title. Oftentimes it has units in there which are helpful to use. Describe this distribution, right? So this one's clearly skewed to the right, unimodal with about 42 knots or so there. We just do all of it. So the shape is skewed to the right. The median would be the middle number. Typically with a skewed graph, the median is the better measure of center. So you would count up, there's 193 of these. 193 divided by 2 is, what is 193 divided by 2? So go to scratch pad, 193 divided by 2. If you want a decimal, you can put decimal in there. 96.5. So between the 96th term and the 97th term, so you would count from the left, 1, 2, 3, 4, I'm not going to count it out. You count from the left to find which bar is between the 96th and the 97th bar, basically. Outliers, maybe an outlier 160, but probably not. It seems somewhat connected there, but it's possible it's an outlier. And then variability, it varies from about 22 to 160. Let's see what they said. Max wind speed values from about 25 to 160. The middle value is 55 knots, so they counted that out there. They did not appear to be any outliers, and again, it was skewed to the right.